Forgot to turn on the sound. Alright, welcome to the live stream. Week 41 will probably be a little bit of a short one today, but hopefully everything will work out. My computer felt a little bit strange when I started the stream, so we will see if everything works out as it should, but hopefully. So let's get started. As you are probably aware, we are commencing to end the course. Maybe not really yet, but there's kind of like 3 weeks left. And the thing that's happened is, of course, the peer review has been finalized, and there's been a couple of questions. And the peer review for this workshop number 2 is a little bit more work to do in general, and also a little bit more spread out in a lot of different ways. Maybe you did not get a whole submission, maybe you just got source code, maybe you got source code in some odd language like C# or Java. But I think you managed to do your best, and that's the main thing, and give as good feedback as possible with the information you got and the ability you got. So that's the main point. Hopefully you learned something, and maybe you even got to see another language that you are not used to, and hopefully you saw that it wasn't really that different, at least maybe not from a design perspective. Yeah, so I hope you enjoyed the peer review, and that you got some good feedback, and that you now can improve your submissions or complete them. And on Friday you are supposed to hand them in my Moodle, and you don't need to include any changes or the previous version like we did for workshop number 1. It will simply be too much to look at. It's quite a large workshop, a large submission as it is, so you don't need to supply any information like that. If you work in a group, you of course need to submit who you worked with, so that we can manage that in a good way. Another thing that's happened is, of course, that workshop number 1 was graded, and I think overall it was a good result in the class. I don't remember really how many that passed, but it was a nice result. The majority of those who got some changes was related to the history of the boat and the berth. So I suggest that you look at that live stream that covers the history, how to solve the problem with historical things in domain modeling. And you should have some good examples and inspiration for how to improve your submissions. And you have until the final submission, or the final day in the course, the 13th of October, to submit. And you do it in my Moodle as usual, on the same workshop tab as workshop number 1. You should have gotten another attempt there. Alright, upcoming is also the test next week. On Wednesday you have the first chance to pass the test. Even if you feel that you haven't prepared, I think you should do the test anyway, if not only to get a feel for the system and how the commenting and stuff like that works. And even if you score low, you have a second chance and a third chance in quite close proximity right now. So please do at least make a try there. All right, I hope everything is working, but it should be. There are at least some viewers. Please say something. All right, let's move on. Workshop number 1 graded as I said. Talked a little bit about the peer review results and the issues there. So next step is, of course, then the final hand-in for workshop number 2. And some things to think about there. Please look at the diagrams that you make. One of the things that we want to see is in this workshop is that you know this transformation of code to class diagram, so that we are sure that this is something that you have proficiency in, that you know how to make a class diagram based on code. So make sure that the class diagram reflects the code, that you have all your classes there, all the interfaces and enumerations or whatnot, that you have the correct relationships between the classes. The major problem is association versus dependency, and sometimes people get confused or make silly mistakes, and then we become unsure when we do the assessment, and it's so unnecessary to fail the workshop because of small errors like that. And also forgetting to put the role name and navigability and multiplicity on the associations is also a common mistake. Please be thorough there, and we want to see that you really know this stuff. So better check it once too many than once too few. And you can look at the crash course for the UML notation there, and you should be able to figure it out, I think. Good, everything seems to be working. There's always a little bit of a worry there. For the sequence diagram, the most common mistake is that you don't show all the calls. For example, you stop somewhere in the diagram and think, well, this is enough. So make sure you follow the call stack, so to speak, so that you go the whole way in the functionality that you decide to show. For example, if you are printing one of the lists or something like that, there is a high likelihood that somewhere a view should get the information from a member to print out on the screen, and we want to see those calls also. Then we have 3 more common problems related to the architecture, and that is that you put view responsibility in the model. And the most common thing is that sometimes we find that you do system out print line, for example, in model, or more common is that you have some form of formatting of strings in model classes. So you create a nice string for a member that you then print in the view, and this is not what you're supposed to do according to the model view separation principle. The next thing is that you have some model responsibility in the view. Most common is that you, for some reason, decide to generate this unique member ID in the controller or the view. And this is a business requirement, something that we want to be able to reuse when we create a new user interface for this member registry. And then, of course, the hidden dependencies. I've been ranting about them before, so I won't talk that much about them, but check for hard-coded constants. That is most likely what we will do when we assess this. Go through the code. If we see any constants, we will start to worry, and we will try to investigate where are these constants connected, and if they are hidden dependencies, you will get penalized for that. And usually we allow kind of like 3 mistakes, minor mistakes, and if you have more than that, then you have some complementary changes that are needed. All right. So please be thorough. This is your chance to show that you have mastered the basics of object-oriented design and class diagrams and sequence diagrams. So please show that. All right, wow, quickly. Moving on. Some of you have started working on workshop number 3. I won't talk that much about it, but the questions that I've got during tutoring is basically, are we allowed to change the code? And yes, you are allowed to change the code. In some of the, I think almost most of the tasks, there are some changes needed to the code that you are given. Would enumerations be considered a hard-coded constant? No, in general not. Since it's kind of like a named constant. So with a hard-coded constant, I mean kind of like a number or a string or a character that you type in several places in the code. But for workshop number 3, yes, you are allowed to change the code, and you need to change the code also to be able to incorporate the changes that are needed to pass the assignment. And as I said in the beginning of the course, workshop number 3 is definitely less work, but maybe more knowledge required. So it's not a super large task really, but it kind of like requires that you know what you are doing. All right, for how is the syntax for packaging sequence diagram? That's a really interesting question. You can use the fully qualified name, for example. So you put several colons. Not all tools support that. You can also kind of like play with colors or something like this. Wouldn't hidden dependencies also include, for example, non-constructor use? I'm not really sure what is meant there. Regarding formatting in model, does that include overriding toString? That's also a good question. ToString used for debug purposes, I think, is fine. If it's used as a mean to print something in the view for the user to look at, then it's not fine. So we can imagine the scenario if we want to support 2 different types of views that want different types of formatting for a member in this case. Then we cannot use the toString method in both places anyway. So, or we need to do some funky parsing of the toString to break it up in different parts and then print it. So avoid using the toString for view purposes or user interface purposes. It's fine to use it for debug purposes. That's why it's there, more or less. All right. I got one question. Okay, so well, it's not a hidden dependency. Using a kind of like using a class in the normal sense, so to speak. So it's not a hidden dependency. So if you remove the data source class in this case, the program will not compile, so the compiler finds this, and then it's not hidden. It could be problematic, of course, using having dependencies for testing and such, and not injecting these dependencies through a constructor. So yeah, it's something to look out for maybe, but it's not not bad per se. And yes, that's the notation, I think, for the fully qualified. I think it's packaged first, really. But you can find the fully classified name notation in the crash course video. All right. So I got one question in Slack for this little live stream. So this question was very interesting, but it was kind of big also. So the question was basically, are there any principles or patterns that kind of like are the opposite of each other, that kind of like compete and are in conflict, so to speak? Yes, there are. Could be an interesting topic for a crash course, or I need to prepare a little bit more to rant about that, because I will probably get something wrong if I just do it from the top of my head. But it touched on a very interesting topic, and it's the topic of different design forces. So maybe you kind of like when you design your little member registry here, you kind of like try to do things good in every possible way, and that is something that is really, really hard, because some design choices are bad for other design choices. So this is called that you have different forces on your design, different kind of like requirements that tug on your design and make it good in some respect and bad in some respect. And this is just a list of a collection of design forces that you can are common in projects that I found from the top of my head. So for example, maybe we have performances. We need to have good performance in our system. It cannot be slow, and this may affect the design in certain ways. At the same time, maybe we have very high requirements on usability. We need to have lots of different user interfaces and support different types of user interfaces. And maybe we also have a desire to reuse parts of our program in other projects, and that also puts stress on the design that we choose and affect the choices that we need to make. Of course, maybe we have very tight deadlines, and that can make us do stupid things or things that are really, really quick but maybe lack in reuse, or maybe are hard to test or something like that. So we have all of these forces that act on our design choices. And in this course, maybe we have chosen to focus a little bit on we talk about you should be able to reuse the model and using a different user interface, and this also maybe plays into usability. We would like to be able to support the development of user interfaces in different ways. We don't really talk that much about testing and security or performance or stuff like that. So and we are not really expecting the system to live very long, but the requirements for the workshop is maybe geared towards having a design that is maintainable, that could live on for a long time and could be understandable by some other people. Do you have to include all classes in the class diagram if you notice that it gets too messy? Can you ignore modulating? I think you should. In this workshop, I would like you to include everything. Everything you yourself write. So yes, it will probably be messy in some cases, but we really want to see that we know that you can do a class diagram based on code. In reality, you always probably need to do some kind of abstraction here, remove some information, because it will get too messy otherwise. again, good tool support would make this more or less easy to do. So everything you yourself code should be in the class diagram, and every dependency and association and whatnot. Alright, but you have these design forces in reality, and you often cannot have everything at the same time. So if you are very pressed for deadlines, it's very hard to make code that is very reusable or very secure or has very good performance, because this stuff takes time. If you have people that are maybe quitting your project, there's coming new people all the time, maybe you should use a simple design rather than something super advanced, and maybe be very strict on your design principles so that it's easier for new people to get into the project. And then maybe it's harder to do really high performance stuff, because maybe you need to make some sheets, so to speak, to get the really high performance. So you cannot often have everything at the same time, and finding a good balance between all of these design forces is quite hard, and especially if they change over time also. The architecture that we talked a little bit about in the course tries to do this and balance different qualities of the system or different forces on the system in some ways, but there's really no perfect architecture that can take everything into consideration here also. So as designers, you often need to try to make decisions, but you should also make decisions so that, okay, now we do need high performance, and this means that maybe it will take longer. We cannot have tight deadlines and high performance, or maybe we cannot have very good reuse if you have high performance, because every piece of code that we write is so specific for this special case to get this high performance that it will be hard to reuse, and things like that. So interesting question. Very hard question to answer shortly, but be aware of these different types of requirements, so to speak, that kind of like drag your design in different directions, and every decision you make as a developer will be affected by these and will affect these also. So it's better to be aware, and I think it says in the book that you need to pick your battles also. Every part of the system cannot be perfectly designed, so some parts will probably be more messy. In, for example, model view controller architectures, controllers are often a little bit problematic. They are very hard to reuse and stuff like that, so they are more or less something that is sacrificed to get a separation of concerns in some way for the model and the views in this case. All right. Lastly, but not leastly, I've continued working on my little student administrative system. Not really that much that has happened. I've implemented parts of the validation that I talked about last session. I've tweaked some of the WebSocket stuff. Apparently Internet Explorer sends Pong messages, unsolicited Pong messages with the WebSocket, so that needed to be handled. And I've also actually implemented that the server acts as a simple web server, so when you can get the index file, so to speak, directly from the server instead of having to open the file. But looking at the validation, I've started with this. The model should be valid by definition, more or less. So if we look at the student, the name and the email are no longer strings. They are different types, an email address type and a NE string type. NE stands for non-empty, so it's a string that has at least one character in it of some kind. And the email address in turn consists of a user, that is a non-empty string, and a couple of domain parts. And this means that starting the system now with these hard-coded stuff looks way more messy than the simple strings that we did. So it's a lot more code, of course. But that is maybe a price you pay for using the type safety system of a language to maybe an absurd level in this case. But it's an interesting exercise. Or maybe look at the email address. So there's an exception class in the email address. So for example, if the domain parts needs to be at least 2 of them, and I think that's more or less it. You always need to check for null values and things like that, but the idea is that if this one is initialized with anything invalid, it will cast an exception, and the same thing is for the non-empty string. It will cast an illegal argument exception that the string is null or empty. All right. You can look at the code if you want to a little bit more in detail, and it's on the course GitHub repository. What you bring up now is probably the most interesting in all the things that I've talked about so far in the course. Include lifecycle design evolution. Yeah, it's an really interesting topic. I will try to do my best about these things. That the problematic part from the course perspective is that it's a little bit out of scope. So it's kind of like this. We are doing quite low level design in the course and trying to where should I put this function, more or less is kind of like the responsibility driven level that we talk about, and a little bit about patterns and stuff. But I agree it's really interesting, so I will see how I can do something interesting about it. Maybe it will be two different videos, who knows. But please fill in, post something on Slack about what you would like to hear more about, and especially during the lifetime of a system. And systems tend to live on for longer than we think. Trends change. For example, continuous integration and especially continuous delivery was really not a thing like 5 years ago. Especially continuous delivery, and that's the shit now. Performance has kind of like changed from being this low level thing you did in your algorithms and stuff like that to being more of a architectural type of thing where you should be able to use microservices and scale up and things like that. So it's good stuff. If an enum class is an inner class, should we modulate it in the class diagram? Modulate, I don't know. Yes, you should have it in the class diagram if that's what you mean. And there's a notation for that. Either you can put it inside of the class, or you can use this anchor notation. It's a circle with a plus sign in it, and then you have a line to the enum, to the inner class. All right. Any more questions? But the notation for inner classes is also in the crash course of the UML notation. Maybe I should do kind of like an image for that, so that you can get everything in one image instead. All right. I don't really have that much more to rant about today. Next week there will be a little bit more tutoring from my side at least. I've scaled it down a little bit this week, but there will be a little bit more sessions next week, I think, especially since we're have the deadline for handing in workshop number 2 there, and it's better that you book a session and get your questions answered instead of and having a good submission instead of having a bad submission, of course. All right, I think it's Friday. I think it's time to wrap it up. Feel free to ask any questions in this Slack channel, and I will answer them as soon as possible. And let's keep the working morale up. There's only a few weeks left of the course, so do your best with these couple of weeks that we have, and hopefully everything will work out in the end. All right, I don't see any new questions in the chat, so let's wrap it up. Bye bye and have a nice weekend.